So, time for our next lesson. This time in the atomic structure topic, we are focusing on chromatography. And this is the first time within the topic that we've looked at one of our separation techniques. Now, last time when we were looking at mixtures, we didn't talk about the idea that actually a mixture can be separated. And that's where this lesson and the next few lessons are going to concentrate. We know that we can have elements and compounds, and that we can have a mixture of elements and compounds. We could just have a mixture of elements, we could just have a mixture of compounds, or we might have a mixture of elements and compounds, and we would start to separate those out into their separate things. So, could be a good opportunity now to recap over the last lesson. Just quickly, can you remember what a compound is? And could you draw in a box a particle diagram that represents a mixture? Pause the video, have a go. So a compound is something that we focused on last time, and we said it is when two or more different elements, and personally I think that is a really important word to get into our definition, when two or more different elements are chemically bonded together. And then if we're interested in a mixture down here, maybe we've got some elements joined like this. Maybe we've got something like maybe water in there as well. Maybe there's another element on its own, and all those things just floating around. So that would be a mixture of elements and compounds. Right, let's crack on. So today we're focusing on the idea of chromatography to separate and identify a mixture, and in particular could be a mixture of food colorings, could be a mixture of all sorts of things. And chromatography is one of the required practicals within GCSE. I'm sure it's been explained to you already that there is a number of practicals that the exam boards require us to teach you and require us to make sure that you do. And basically it's because they're going to come up in the exam at the end of all of this. Okay, our purple word for today is chromatography, and we've got a term down there, the RF value. That's also a purple term, so have a look in your glossary for the purple words as we're going through. So we're going to successfully carry out paper chromatography. Well, not actually carry it out unless you've got the equipment at home, but we're going to watch a video related to that, and the link for that and the link for anything like this BBC bite-sized link will be in the description below. You're going to be able to collect a set of results that enables a separate dye to be identified. Maybe there are 3 or 4 dyes within a substance. We'd be able to identify them using the RF values. So you're going to be able to calculate the RF value of different dyes. So first task, this is recalling keywords from the last lessons. So test yourself on the keywords that you have written down over the last 2 lessons. Can you recall the definition of each of the following? Lots and lots of definitions just there. So pause the video, see if you can come up with the definition of each of those. So, loads of keywords from the last few lessons, and the introduction of some keywords to you right now. Here are some new ones. These keywords are used when discussing mixtures, so obviously very important when we're talking about separating mixtures. They are not, however, in a lot of the glossaries of textbooks. Quite often they're actually highlighted in a textbook as being in the glossary, but they aren't actually there. For example, the AQA GCSE chemistry textbook that we use at our school. But hey, so we've got a solvent, a solute, a solution, something that is soluble and insoluble. Apologies for all of these words, basically looking the same, but hey, chemists back in the 1800s came up with all these words, so let's blame them. So see if you can define and link all of these. Now, investigating paper chromatography. So chromatography is a method of separation in which different coloured dyes can be distinguished individually. Chromatography works by passing a solvent through the mixture. Solvent is something that does the dissolving of a solute. This separates as the different dyes are drawn up through the paper, dissolved in the solvent, and at different rates. So we might have an example like the picture on the right hand side, where we've got a black dot, he says, writing in blue pen, a black dot there on a piece of paper. And as the solvent, the water here, starts to be soaked up, up there, and you can see it on the diagram on the right, this water has been soaked up. It drags the ink spot up, but it drags the different colours at different rates, and it separates them out into all of those different colours on the paper, so we'd be able to identify those. Extension task just there. Can you research how chromatography is used to solve crimes? Right, some key terms for chromatography, and these are lots of the words that we used earlier. So solvent, that's something that's able to dissolve other substances. Something called the solvent front. So as the solvent soaks up through the paper, the point at which the solvent reaches when you finish is called the solvent front. So the furthest point to which the solvent has travelled up the chromatography paper. And then this term just here is super important, this RF value. This is a measurement to define how far a compound has travelled. So if we had a piece of chromatography paper where that was the start line and that was the finish line, but a compound, let's say it's that blue dot, okay, and let's say that compound has moved from there to there, that's the distance travelled by the compound. But the solvent front is the distance travelled from the start line to the solvent front just there. So the distance travelled by the solvent is that distance. So it's a ratio of the distance travelled by the spot to the distance travelled by the solvent. And that is unique for a compound. So every compound has a unique RF value. So this is obviously slightly tricky because you are sat watching a video. You don't have all the equipment out in front of you unless you live with a chemistry teacher or have a big chemistry set or have just been onto Amazon. Who knows? So can you write a method for the practical shown in this video? So I'm going to put a link to this video in the description below, and it is from a school that have put all of the required practical videos up. So please do take a look to all of those because they are wonderful. And I'd like you to write a method for the practical. Remember, really good method is numbered, just like a good recipe within a book. Now, when methods come up at GCSE in exams, there are usually 6 marks available. So be as detailed as possible. Right. How to calculate an RF value. So an RF value is the ratio between the distance travelled by the solvent and the distance travelled by the solvent. I said that wrong. Distance travelled by the solute and the distance travelled by the solvent. Got to be very careful there. Okay, so on the example on the left-hand side, our compound has moved up by 4 centimetres and our solvent has moved up by 8 centimetres. So as it says down the bottom, 4 over 8. So the RF value is equal to 0.5. Okay, and that is unique for that red ink in the question. So there are some exam style questions that go along with this PowerPoint, and they are handed out to my students. I've sent them to them. I will try and put a link below to like a Google document or something where they can be found. In fact, they can be found just here. So we've got bronze question. So have a go at that, press pause and work through. So there's your answers. Why is a baseline drawn in pencil Okay, the fact that it's drawn in pencil is really important. Pencil is insoluble. If I was to use ink, the ink would get drawn up with the solvent because ink is soluble, so it could affect the results. One of the dyes doesn't move during the experiment. State a reason why and what the student could do to make it move. If a dye doesn't move, it's because it's insoluble in that solvent. So a way to change that is to experiment using different solvents that might be able to dissolve it and drag it up the paper. That's a tricky question. Silver. Okay. If you want a bit more of a challenge, try this one. Some working out there. So just check back with your equation for the RF values. And here's your answers then. So what does the chromatogram tell us about the black ink? So the chromatogram, so the black ink, we're interested in that just there. Now we know that it is made of 1, 2, 3 different colours. We know that one of them is the blue because it goes to the same height, and we know that one of them is the green, and we know that this yellow just here doesn't match up. There is no big spot just there, okay, even though it slightly looks like there might be on the PowerPoint, but never mind. Calculate the RF value of the green ink. So it gives you the value here as 8 centimetres, and it gives you the value for the solvent front as 10. So 8 over 10 is equal to 0.8. Right, the gold question. Drugs are sometimes used by athletes to enhance their performances. All medal-winning athletes are required to provide a urine sample at the end of their race. The urine samples are tested using chromatography to test for illegal substances. Describe the method used and explain how you'd be able to tell whether illegal drugs had been taken. That is really key to get all of your full marks in the question. So have a go at that. And here's your answer. So describing the method, so what you were working on earlier in the lesson by watching that video and coming up with a method. And then the important thing at the end is this point. If any of the spots formed by the illegal drugs match spots in the urine sample, then unfortunately the athlete has taken drugs. They will be immediately stripped of their medals and banned from the sport. So in chromatography, we have to compare the RF values that we get with known substances. So there would be a list of illegal drugs and all of their RF values because they're unique for every compound, and you'd have to compare it against that list. So, the end of another lesson. Get the key points down as bullet points, or get all the key points, summarise everything, maybe draw some diagrams on a tiny little post-it note to reduce all the information down, or try using flashcards. I would take this opportunity, if I was you, to go back over the notes for today and maybe have a look back at the videos on the previous 2 lessons as well. Bye for now.